So this is 6.5. I'm not sure what page it's on, but they talk about reflections and they give you some examples in your book. And the third type of reflection, which I'll go over here in a moment, I think they really do a poor job of explaining that one. It's so much easier. They make it so much more complicated than it needs to be. But when you reflect something, it's like if you look at a mirror, you're seeing a reflection of yourself. And there's three types of reflections, and I want you guys to be looking up here, otherwise you're going to be lost, okay? The first type of reflection is you're reflecting the x-axis. The second type of reflection is you're reflecting the y-axis. And the third type of reflection is you're reflecting both axes, okay? If that's the right word, I'm not sure. So I'm going to go over reflecting the x-axis first. And I wrote it down how you would do that. You would reflect the x-axis, and you would use the same coordinate and the opposite y. Because if you guys remember, when you are given a coordinate pair, the x is always the first coordinate, and the y is always the second coordinate. So let's look at this example. I've got several examples actually for both. Look at this one right here. It's 1, 4. So if I want to reflect the x-axis, the x-coordinate stays the same. Use the same x-coordinate. That stays the same. And the y-coordinate is the opposite. Keep your mouth shut. Okay? And so what's the opposite of 4? -4. And so you can see where that point is reflected. In other words, here is the original point, 1, 4. Its reflection would be 1, -4. Let me give you another example. If I wanted to reflect the point 8, 3, and now I'm reflecting on just the x-axis we're talking about, the x stays the same, and then I put the opposite of the y value. So it's 8, -3. Now I could also, maybe I'll give you a point that's 8, -3, and I said reflect that on the x-axis. What would the x-axis reflection be? Well, it would be 8, 3, because remember the x value stays the same when you're reflecting the x-axis. Let's look at another one. How about if I gave you -8, -5? What stays the same? -8 stays the same. What's the opposite of -5? 5. So there's its reflection. Okay? So that's 3 examples on reflecting the x-axis. If you reflect the y-axis, it's the same thing, but in this case, the y-coordinate stays the same, and it's the opposite x. So look at this one. Let's see, reflect the y-axis, use the same y-coordinate and the opposite x. So look at this one, for example. We have -3, -3. The x-axis stays the same, and the opposite y. Wait a second, I have that one wrong, I think.
X is the opposite.
Yeah, so let's cancel those out. Made a mistake there. Let's look at the other one. Let's see if I did that one right. Reflect the y-axis, use the same y-coordinate. Did I mess up on that one too? I did, didn't I?
On both of them.
Yeah.
All of them.
Well, let's do another one then here. So let's do this one. How about right here? What's the coordinate of this point?
-7.
-7, comma what?
2.
2. Okay, so if I wanted to reflect that on the y-axis, use the same y coordinate,
It would be -7, -2, 2.
and use the same y coordinate,
It would be 7, 2.
so it stays 2, and then it would be 7,
Oh, comma 2.
7,
Comma
comma 2. Let's do another one. How about right here? What's the coordinate of that point?
-2, -6.
Yep, -2 is the first one listed, and then -6. Okay, so reflect the y-axis, use the same y coordinate, so it is -6,
And
and then what's the opposite of the x?
2.
2. So it's 2, comma, -6. All right? You guys see that? All right. The last one I want to show you, and I'll move this right up, right to there, I think, is reflecting both axes. And all you're doing is writing down their opposites. So, for example, look at this one right here. It's -5, 6. What's the opposite of -5, 6?
5, -6.
5, -6. And so you'll notice that right here. 5, -6. How about this one right here? 8, 9. What's its opposite? -8, -9. Now, one last thing I want to show you. When you reflect both axes, there's something that takes place. Watch what happens here. So let's look at 8 and 9, and I'm going to start there, and I'm going to go down to its reflection, -8, -9. What happened? Where did that line go?
Right through the origin.
Right through the origin. Look at this one up here, -5 and 6. So I'll start there, and I'll go down to 5, -6. Right through the origin. So if you've done both axes correctly, if you're reflecting both, it'll always go right through the origin if you draw a line between the 2 points. Okay? Now, something else you may not have noticed, if you've done the y, if you're reflecting the y coordinate, what's going on here? It's a straight line crossing the y-axis. If you've done the x-axis correctly, what's it doing?
Going a straight line right through the
Right through the x-axis, a straight line. All right? Questions on this, anybody? Even though I messed up when I wrote this down after school yesterday on the y's. You guys got it? So, I'll leave this up, or you can watch the video again later. One thing, although they have the same information in your book, you might, whoops, hit undo. You might want to write that down and write that down. Their example of reflecting both, I think it's confusing. So I would just remember you just change the sign of both X and Y. All right, so here's what I want you guys to do. Whoops. I want you to write down those points. You already have your handout. So the blue ones, you're reflecting the x-axis. The red ones, you're reflecting the y-axis. And the black ones, you are reflecting both x and y. Okay, questions on this?
So black ones are Y on it?
It says it right up there. The black ones are both x and y. I'm going to add one more here, I think.
Do you have to, like, can you just draw them all with a pencil, or do they have to get color?
I would prefer if you could color coordinate it, that would be great.
Does anyone have any pencils?
Well, then I guess you'd have to borrow one from somebody. Imagine that. All right, so I added one more black one, -9 and 1. All right, I'm going to end this video.